Okay, this video is going to be about interpreting chemical equations. If you haven't watched the first video about chemical equations to begin with, I would recommend going and watching that first and then coming back to this one when we're done with that. All right, so how do we interpret chemical equations? So here's an example of a chemical equation. I think this is the same example we used in our last video. And one way to interpret this is we just take the formula names for all of our different compounds in addition to the states of matter that they have, and we're going to combine them all together into a sentence. For example, calcium chloride solution reacts with sodium carbonate solution to produce solid calcium carbonate and sodium chloride solution. Again, here's our calcium chloride solution. The AQ tells us that it's a solution dissolved in water. The sodium carbonate, again, AQ tells us that it's dissolved in water. To produce, that's what this arrow means, calcium carbonate solid and sodium chloride solution. Again, aqueous being solution. So that's how we would take this equation and turn it into a sentence, what we call interpreting that equation. Now, if I were to carry out this chemical reaction, what would I expect? What would I predict as far as what my reactants are going to look like, what my products are going to look like? What is that chemical reaction going to look like? I want to make a prediction so that when I do it, I know if I'm getting what I thought I was going to get. So again, here's our equation. And I would say that two clear liquids are mixed together to produce one clear liquid and a precipitate. Again, two clear liquids that we're starting with. Okay, here are my two liquids. Okay, remember, solutions are always clear, not always colorless, but they are always clear. And I'm going to produce one clear liquid, and that's this solution over here, my sodium chloride solution. And I'm going to produce a precipitate. Again, I'm going to produce a solid. Here's my calcium carbonate here. So if I was to predict, I would say, okay, I'm going to have two clear liquids. I'm going to mix them together, and I should get a clear liquid. I should get some solution, and I should get a solid, some sort of precipitate. If that's what I get, I probably made a correct prediction. If I get something different, then I have an incorrect prediction, an incorrect hypothesis, and those are always fun because that means I learned something. Here's another example of interpreting an equation. Here's a chemical equation here. If I were to interpret this, I would say that sodium chloride crystals or sodium chloride solid are dissolved in water. I know they're going to be dissolved in water because it's going from solid to aqueous, and I'm going to produce aqueous sodium chloride or a sodium chloride solution. So that's how I would interpret this chemical equation. If I was going to predict what my reactants and what my products are going to look like, again, here's my equation. A crystal or a solid is dissolved in water to produce a clear liquid, a solution. That's a fairly simple chemical reaction. Again, here's my crystal, here's my solid, and here's my clear liquid. This is my solution that I'm going to create as I dissolve my solid in water. Last one, last example. Here is my chemical equation. So if I was going to interpret this, I would say that aqueous sodium carbonate is added to aqueous acetic acid to produce aqueous sodium acetate, water, and carbon dioxide gas. Again, this is a little bit more complicated chemical equation. Here is my sodium carbonate, aqueous, acetic acid, aqueous, and then my sodium acetate. If you don't remember how to name these or how to go from the equations to the names, feel free to look these up. That's what I have to do sometimes if I don't know it offhand. Now, when I'm going to predict what this is going to look like, this is going to be a little tricky, and I'll show you why when we get to the products, how this can sometimes trick us up a little bit. So here is my chemical equation, and I have two clear liquids, right? Two solutions that I start with, and I'm going to mix them together, and I'm going to produce one clear liquid. Be careful there, one clear liquid, and I'm going to produce some bubbles. The one clear liquid I'm going to make is going to be my solution and my water, because when they're mixed together, I can't tell the difference between them. So I can't see that I have sodium acetate in solution and water. I can't tell the difference between those. Now, in order to tell that I have sodium acetate in solution, I would just need to evaporate away my water, and then I'd be able to test it and see, yes, I actually do have sodium acetate. But during this chemical reaction, I would not be able to see the difference between those. So I'm going to have one clear liquid, and I'm going to produce bubbles. I know I'm going to produce bubbles because I'm making a gas. And anytime I have a liquid that produces a gas, I'm going to see bubbles. So here are a couple of examples of predicting both reactants and products, what you are going to see.